January 17, 1943, 27,000 feet above Wilhelmshaven, Germany. The air at this altitude is thin enough to kill a man in minutes. Inside the unpressurized fuselage of a Boeing B-17F, the temperature hovers at 40 degrees below zero. Ice crystals form on every metal surface. The breath of 10 young Americans turns to fog inside their oxygen masks. Through the plexiglass nose, Bombardier Lieutenant James McClure watches the North Sea give way to the German coastline, a gray smudge against white snow. His gloved hands rest on the bomb sight, fingers already numb despite the heated suit beneath his flight jacket. Behind him, the aircraft shudders as flak begins to burst in black flowers against the winter sky. This is the sound men will remember for the rest of their lives. A hollow crump that arrives before the shrapnel, followed by the metallic rain against aluminum skin. McClure counts 7 holes punched through the nose cone in as many seconds. The plexiglass spiders with cracks. Wind screams through the gaps, and still, the fortress flies. This is not the first bombing raid over Nazi Germany, nor the deepest penetration into defended airspace. But January 1943 marks the moment when the Luftwaffe High Command begins to realize they are facing something unprecedented in the history of aerial warfare. Not simply another bomber, but a philosophical statement rendered in aluminum and Wright Cyclone engines. The B-17 Flying Fortress arrives over Europe carrying more than high-explosive ordnance. It carries an idea that will reshape how modern nations think about strategic power, industrial capacity, and the terrible arithmetic of attrition warfare. The Germans will throw everything they have at these formations: cannon fire, rockets, even bombs dropped from above. They will develop tactics specifically to destroy them, and yet, month after month, the fortresses keep coming.
The name itself, Flying Fortress, was not born from military designation, but from a journalist's astonishment. When Boeing unveiled the Model 299 prototype at Boeing Field in Seattle on July 28, 1935, a reporter from the Seattle Times stared at the array of gun positions bristling from the airframe and coined the phrase in his copy. The Army Air Corps had requested a multi-engine bomber to defend American coastlines. What Boeing delivered looked less like a defensive weapon and more like a castle with wings. 5 machine gun positions, a wingspan of 103 feet, 4 engines generating 4,800 horsepower combined. The Air Corps had asked for a bomber that could carry a ton of bombs 2,000 miles at 200 miles per hour. Boeing's engineers, led by E. Gifford Emery and Edward Curtis Wells, delivered an aircraft that exceeded every specification and introduced a new vocabulary to aerial warfare. This was not a bomber that would run from fighters. This was a bomber designed to fight its way to the target and back. But in January 1943, above Wilhelmshaven, theory meets the most brutal testing ground imaginable. The Luftwaffe fighter pilots climbing to intercept the American formation are not impressed by names or specifications. They are veterans of the Battle of Britain, the Eastern Front, and the Mediterranean. They fly Focke-Wulf 190s and Messerschmitt 109s, aircraft refined through 3 years of total war. Their tactics for bomber interception have evolved into deadly science. Come in from 12 o'clock high, where the forward guns have limited range. Target the cockpit and kill the pilots, or aim for the engines. One good burst into a Wright Cyclone and the fire will do the rest. The German pilots have studied American bomber formations, noted the gaps in defensive fire, calculated the angles of attack that minimize exposure. They expect the B-17s to break formation once the attack begins, to scatter like all bombers do when fighters press close. They expect panic.
What they encounter instead will fill Luftwaffe after-action reports with a tone approaching disbelief. The B-17 does not break. The formation tightens. From every gun position, 50-caliber machine guns begin tracking targets with disciplined fire. The waist gunners, standing at open windows in sub-zero air, swing their weapons through practiced arcs. The ball turret gunner, suspended beneath the fuselage in his plexiglass sphere, rotates to meet attackers from below. The tail gunner, isolated in his position at the rear of the aircraft, has the clearest field of fire of any position in the bomber. Each gun throws 800 rounds per minute. Each round weighs half an ounce and travels at 2,900 feet per second. When a B-17 formation of 18 aircraft puts up defensive fire, the air becomes a geometric web of tracers. The Luftwaffe pilots discover that pressing an attack through this fire requires a level of courage bordering on fatalism. Oberlieutenant Heinz Knoke, a Luftwaffe ace who will survive the war with 33 confirmed kills, records his first engagement with B-17 formations in his combat diary. "They came on as if nothing could stop them," he writes. "Our attacks seemed to make no impression. We would see hits, see pieces fly off, see engines trailing smoke, and still they held formation." This is the psychological impact the fortress is designed to create. Every structural element, every redundant system, every piece of armor plate is engineering translated into morale. The pilots and crew who fly in B-17s know their aircraft can absorb punishment that would shred any other bomber in the sky. This knowledge changes how they fight. The German pilots expected men who would flinch. What they meet are formations that fly straight through fighter attacks to reach the bomb release point, then turn around and fly straight back through the same gauntlet. The cost is staggering on both sides. On this January raid over Wilhelmshaven, 3 B-17s go down.
7 more return so badly damaged they will never fly again. But 50 aircraft drop their bombs within 1,000 feet of the aiming point, and the submarine construction yards that are the primary target suffer damage that will delay U-boat production by 6 weeks. The Air Corps planners study the loss rates and the photographs of the target and conclude the equation is sustainable. 3 aircraft lost, 7 destroyed beyond repair, but the mission succeeds. This is the terrible mathematics of strategic bombing, and the B-17 is the tool that makes the math work. To understand why this aircraft earns its legendary status, one must understand what it replaced and what it represents. In 1939, most military aviation doctrines still treated bombers as fragile assets that required fighter escort throughout their mission. The bomber, in this thinking, was a payload delivery system that happened to fly. It needed protection the way a cargo ship needs destroyer escorts. The B-17 inverts this assumption. It is designed from the first rivet to be a weapons platform that happens to carry bombs. The difference is subtle but profound. Every design choice prioritizes survivability and defensive firepower alongside bomb load and range. The result is an aircraft that can operate in environments where other bombers simply die. Consider the structural engineering. The B-17's fuselage is built around a cruciform structure, 4 main spars running the length of the aircraft with cross-bracing every few feet. This design distributes stress across the entire airframe. A single hit, even a catastrophic one, rarely causes total structural failure. There are documented cases of B-17s returning to base with holes large enough to crawl through, with entire sections of tail surface missing, with 2 engines dead and a third on fire. The aircraft absorbs damage and continues to fly because it is designed with redundancy at every level. Hydraulic systems have backup manual controls.
Fuel is distributed across multiple self-sealing tanks. The control cables run in parallel along opposite sides of the fuselage, so that one burst of shrapnel cannot sever all connections simultaneously. This is not accident. This is intentional design philosophy that values crew survival as much as mission success. The men who fly these aircraft understand this trade-off intimately. They know that the B-17 is not fast, maximum speed of 287 miles per hour, slower than most contemporary fighters. They know it is not particularly maneuverable at high altitude, where the thin air makes control input sluggish. What they trust absolutely is that the fortress will bring them home if they do their jobs. This trust becomes the foundation of morale in the 8th Air Force bomber groups that operate over Europe. Crews name their aircraft, paint elaborate nose art, and develop superstitions about individual planes. Ships with reputations for bringing crews back safely become legendary within their squadrons. Hell's Angels of the 303rd Bomb Group, Memphis Belle of the 91st. These names represent more than aircraft. They represent proof that survival is possible, that the mission can be completed, and the crew can live to fly again. The Luftwaffe, studying this phenomenon, attempts to break it through brute force. By mid-1943, German fighter groups are equipped with aircraft modified specifically to destroy B-17s.
The FW-190 receives additional armor plating and heavier cannon, twin 20mm guns supplemented with 30mm weapons firing explosive shells. Some Messerschmitts mount 21cm rockets under the wings, unguided weapons designed to be fired into bomber formations from beyond machine gun range. The tactic is brutally simple. Break up the formation so individual bombers can be picked off without mutual defensive fire. On paper, it should work. In practice, the execution proves more difficult than the planning.
B-17 pilots learn to fly in stacked formations, where each aircraft's guns cover the vulnerable zones of its neighbors. The combat box formation, developed through trial and blood, places 18 bombers in a three-dimensional arrangement where any attacking fighter must fly through converging fields of fire. The mathematics favor defense. A fighter has seconds to aim and fire before the closing speed carries it through the formation. A bomber crew has continuous tracking time and dozens of gun positions. The exchange rate favors the fortress. But this is not a bloodless calculus. Inside the bombers, the reality of combat at 25,000 feet is primal and terrifying. The waist gunners stand at open windows where the wind chill can reach 80 degrees below zero. Their oxygen masks freeze to their faces. Their heated suits short out with alarming regularity. When a fighter makes a beam attack, coming in perpendicular to the bomber's flight path, the waist gunner has perhaps 3 seconds to track, lead the target, and fire before the moment passes. Miss, and the fighter pilot gets a clean shot at the bomber's fuselage. The ball turret gunner operates in even more claustrophobic conditions, folded into a sphere less than 4 feet in diameter, hanging beneath the aircraft with only plexiglass between himself and empty space. If the aircraft has to make an emergency landing with the ball turret damaged, the gunner cannot exit his position. He rides it down and hopes the landing gear deploys. These men, average age 22, execute their duties with a precision that the pre-war planners could only hope for. They do it because they believe in the aircraft they fly, and because their survival depends on each other. The bomber offensive over Europe becomes a campaign of accumulation. Each raid adds data points to the operational research. The Air Corps learns which formations work, which altitudes optimize survival versus accuracy, which targets justify the losses.
And the losses are continuous. On October 14, 1943, during the second raid on Schweinfurt, a deep penetration strike against ball-bearing factories, the 8th Air Force sends 291 B-17s into Germany without fighter escort. 60 do not return. 17 more are damaged beyond repair. Another 121 require significant repairs. The raid is tactically successful. The factories are hit, but the loss rate of 26% cannot be sustained. After Schweinfurt, deep penetration raids are suspended until long-range fighter escorts become available. This is the harsh reality that even the flying fortress cannot overcome pure attrition without support. Yet the aircraft's reputation only grows. The stories that come back from the crews who do survive read like technical miracles. There is the B-17 All-American of the 97th Bomb Group, which collides with a German fighter over Tunisia. The collision nearly severs the fuselage just aft of the wing. The tail section remains attached by only the bottom longerons and a few cables. The pilot, Lieutenant Kendrick Bragg, keeps the aircraft in formation for the bomb run, then flies 90 miles back to base. The tail section twists and bends but does not separate. The crew evacuates after landing, and the aircraft is surveyed as a constructive total loss, but it flew. Photographs of the damage circulate through every bomber group in the theater. If a B-17 can fly home while nearly cut in half, then perhaps any damage is survivable. This mythology is not accidental. The Army Air Forces understand the value of these stories for morale and recruiting. The tale of Memphis Belle and her crew becomes a full-length documentary film directed by William Wyler and shot in combat over Europe. The film shows actual combat footage intercut with narrative sequences. American audiences in 1944 watch B-17s absorb fighter attacks and flak bursts, watch engines burn and wings shatter, and watch the bombers continue flying.
The message is carefully crafted. American industrial might produces weapons so superior that even overwhelming odds can be defeated. This is psychological warfare aimed at both the home front and the enemy.
For American civilians, it justifies the sacrifice and the ration cards. For the Germans, it suggests that resistance is futile against an enemy with such resources. The reality, as always, is more complex than the propaganda. B-17 production represents one of the greatest industrial mobilizations in history. Boeing's Seattle plant, Douglas facilities in Long Beach and Tulsa, and Lockheed's Vega division in Burbank combined to produce 12,731 B-17s between 1939 and 1945. At peak production, the factories deliver 17 aircraft per day. This scale of manufacturing requires a supply chain that stretches across the continent. Aluminum from Alcoa smelters, Wright Cyclone engines from plants in New Jersey and Ohio, instruments, radios, guns, ammunition, tires, plexiglass, wiring, each component sourced from specialized suppliers. The logistics rival the combat operations in complexity. A single B-17 contains 400,000 individual parts. Keeping bomber groups operational in England requires a continuous stream of replacement aircraft and spare parts shipped across the Atlantic through U-boat-infested waters. The Flying Fortress is not just an aircraft. It is the visible manifestation of American industrial capacity. The German war planners recognized this reality, even as their fighter pilots engaged the raids. Albert Speer, Hitler's Minister of Armaments and War Production, understands that Germany cannot match American production tonnage. His strategy focuses on efficiency and concentration. Build fewer weapons, but make them more effective. German factories produce excellent aircraft, but in numbers that cannot replace losses at the rate required. By contrast, American production assumes attrition.
The B-17 is designed to be repairable in the field and replaceable when necessary. Damaged aircraft are cannibalized for parts. Write-offs are accepted as routine costs. When a bomber group loses 5 aircraft on a mission, 5 new aircraft and crews arrive within days. This is logistics as weapon. The Germans shoot down bombers faster than they expect, and the bomber stream continues undiminished. The psychological impact on Luftwaffe pilots is corrosive. They are winning tactical victories in individual engagements while losing the strategic campaign through exhaustion. Inside the fortress, the crew experiences this strategic reality as survival measured in missions. A full tour of duty for 8th Air Force bomber crews is initially set at 25 missions. The odds of completing 25 missions in 1943 are approximately 1 in 4. Most crews are shot down, killed, or captured before reaching the halfway point. The men who beat these odds develop superstitions, rituals, and a fatalistic humor that outsiders find incomprehensible. They paint names on their aircraft that mock death. They carry talismans and refuse to fly without specific items of clothing. They trust their aircraft with a fervor that borders on religious belief. And when a crew does complete their tour, the celebration is muted because everyone knows the statistics. They have survived what probability said was impossible. The Germans, observing this system, draw conclusions about American ideology that will shape their strategic thinking for the remainder of the war. To the Nazi leadership, the willingness to accept these casualty rates suggests either fanaticism or an industrial capacity so vast that human losses are irrelevant. Both interpretations are disturbing. The Luftwaffe fighter pilots, writing letters home and filling out combat reports, express grudging respect for the American aircrews. They note the discipline of the formations, the accuracy of the defensive fire, and the refusal to break off attacks regardless of damage. Heinz Kudrock, in his diary, writes, "These men are not cowards. They are as brave as any German pilot, but they have something we do not, an unlimited supply of aircraft. They can afford to trade losses in a way we cannot." This is the truth the Flying Fortress reveals. Modern industrial warfare is not decided by individual heroism or tactical brilliance, though both remain essential. It is decided by which nation can produce more weapons, train more crews, and sustain losses longer than the enemy. The B-17 is optimized for this type of conflict. It is not the most advanced bomber design of the war. The later B-29 is pressurized, faster, and carries a heavier bomb load.
But the B-17 is available in numbers and reliable enough to operate continuously in the worst conditions. These qualities matter more than maximum performance specifications. The Fortress is designed to be good enough in sufficient quantity to accomplish strategic objectives through cumulative effect. The symbolic power of the aircraft extends beyond its combat record. For American crews, the B-17 represents protection, a machine that brings them back from hell. For ground troops fighting in Europe, the sight of B-17 formations overhead represents support, the knowledge that strategic targets behind enemy lines are being systematically destroyed. For German civilians, the silhouette of a fortress formation means sirens, shelters, and fire. The psychological landscape of the war is shaped by these perceptions. An aircraft becomes more than metal and fuel. It becomes a symbol of which side controls the future. After the war, when analysts total the numbers, the strategic bombing campaign's effectiveness remains debated. Did the bombing of German industry shorten the war? Did the cost in aircrew lives justify the results? These questions do not have simple answers.
What is quantifiable is the effect on German war production and morale. By 1944, Germany is forced to disperse manufacturing, divert resources to air defense, and operate under constant disruption. Fighter aircraft that could be used on the Eastern Front are instead committed to defend the Reich. Anti-aircraft guns that could support ground troops are fixed in place around cities and factories. The bombing offensive forces Germany to fight a defensive war in its own airspace, and the B-17 is the primary tool that imposes this burden. The flying fortress also changes how future wars will be fought. The concept of strategic bombing, using air power to destroy an enemy's capacity to make war rather than simply supporting ground operations, becomes doctrine for the newly independent United States Air Force after 1947. The B-17's operational history provides the template: long-range strikes, daylight precision bombing, and acceptance of losses in exchange for strategic effects. Every American bomber developed in the Cold War traces its lineage back to the fortresses over Europe. The B-52, still in service 8 decades later, is a direct descendant in philosophy, if not design. The willingness to build expensive, heavily defended bombers that can operate in hostile airspace without fighter escort is a strategic choice that begins with the flying fortress. But for the men who flew them, the aircraft is never about doctrine or strategy. It is about trust. Trust that the pilots can hold formation through flak and fighters. Trust that the bombardier can find the target through clouds and smoke. Trust that the navigator can guide them home when half the instruments are shot out. Trust that the gunners will keep the fighters at bay long enough to reach friendly airspace. Trust that the engines will keep running despite damage and cold. Trust that the airframe will hold together when logic says it should disintegrate. This trust is not blind faith.
It is earned through repeated proof that the fortress does what it was designed to do. There is a mission flown on February 3, 1945 that distills this essence. The target is Berlin, and the weather is catastrophic. Cloud cover from the English coast to the target. Icing conditions. Visibility near zero. The mission planners debate scrubbing the raid, but intelligence indicates that the Luftwaffe has dispersed fighter production to facilities in Berlin that have never been hit. The decision is made to go. 1,200 heavy bombers take off in waves. The B-17 formations climb through solid clouds for 40 minutes, relying on instruments and spacing discipline to avoid collisions. They break through at 23,000 feet into clear sky above the weather. Below them, Germany is invisible under unbroken white. They fly the mission on dead reckoning and radar, drop their bombs on instrument readings, and turn for home. The return flight is through this same weather. Several aircraft, low on fuel and unable to find their bases in England, divert to emergency fields or crash land in open country. 11 bombers are lost, but the raid hits 5 separate factory complexes. The after-action photographs show precision bombing executed in conditions that should have made the mission impossible. This is what the Flying Fortress enables. Operations that would be suicide in any other aircraft become routine. The baseline of what is possible shifts. Commanders plan raids they would never have attempted before the B-17 because the aircraft's capabilities expand the envelope of feasible missions. This operational flexibility is perhaps the most important contribution the Fortress makes to Allied victory. It gives strategic planners a tool that can be used in almost any weather, against any target within range, with acceptable loss rates. The word acceptable carries enormous weight. Acceptable means that the mission can be repeated.
Acceptable means that crews will continue to volunteer. Acceptable means that the strategic objective justifies the human cost. In the final accounting, the B-17 Flying Fortress proves that aerial warfare has become industrial warfare. The side with greater productive capacity, better logistics, and willingness to sustain a campaign of attrition will prevail regardless of tactical elegance. The Fortress is not beautiful in the way a fighter aircraft is beautiful. It is a functional, utilitarian machine optimized for a single purpose: to carry bombs to distant targets and bring crews home. That it does this job while under attack from the most advanced air defense system in the world is the achievement that earns the name. The last combat mission flown by B-17s in Europe occurs on April 25, 1945, just days before Germany surrenders. By this point, the Luftwaffe is effectively destroyed. Fuel shortages ground most German fighters, and those that do fly face overwhelming Allied air superiority. The fortresses fly through empty skies, their defensive guns silent for lack of targets. The crews who fly these final missions feel an odd sadness mixed with relief. They have survived what so many did not, but the aircraft that brought them through has become obsolete even as the war ends. Jets and rockets represent the future. The piston engine bomber, no matter how legendary, is already history. But in that history lies a truth about how nations mobilize for total war and what tools they build to win. The Flying Fortress is not the best bomber because it is fastest or carries the most bombs. It is the best bomber for the mission it was designed to accomplish, flying through the most heavily defended airspace in history, day after day, until the enemy's capacity to resist is destroyed. It does this not through elegance, but through brute competence. Every system redundant, every failure mode considered, every ounce of defensive armament utilized.
The result is an aircraft that becomes synonymous with American air power in the same way the Sherman tank becomes synonymous with American armored warfare, not because it is superior in every metric, but because it is present in overwhelming numbers and reliable enough to get the job done. For Lieutenant James McClure, the bombardier who watched flak punch through his nose compartment over Wilhelmshaven in January 1943, the Fortress represents something simpler. It is the machine that did not fail him when failure meant death. He will fly 19 more missions in B-17s before his tour ends. He will watch other aircraft go down trailing fire, will see friends die in aircraft identical to his own, will experience the random cruelty of combat, where survival is determined by inches and seconds. But he will also experience 20 missions where the Fortress absorbs damage that should be fatal and keeps flying. On his last mission, the aircraft returns with one engine dead, hydraulics failing, and 180 holes counted by ground crew. It lands safely. McClure touches the aluminum skin as he climbs out, a gesture half farewell and half gratitude. The Fortress has earned its name not in propaganda or theory, but in moments like this, repeated thousands of times across 3 years of war. It flies when flight should be impossible. It survives when survival should be impossible. And it brings its crews home through the worst that modern war can inflict. This is the meaning of the name. Not fortress in the sense of static defense, but fortress as mobile protection, a castle that flies into battle and shields the men within. The Germans learn this truth through painful experience. The Americans build doctrine around it, and the crews who fly the missions understand it in ways that words cannot capture. Only experience, only survival, only the memory of cold sky, and the sound of engines that never quit.